Okay, thank you. Next is the welcoming speech by Dean Faculty of Computer Science, Mr. Vijayanto, Master of Education, Master of Computer. To Mr. Vijayanto, time is yours. Mr. Vijayanto? Hello? Are you ready?
Okay, my voice is clear?
Okay, Mr. Vijayanto.
Okay.
Okay, time is yours.
Okay. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good morning, ladies and gentlemen. Welcome to Duta Bangsa University, Surakarta, Central Java, Indonesia. Thanks to us for everyone of you for being here today at online Zoom media. I'm glad to meet you. I'm sure you all in good health on pandemic COVID-19. Before we get started, I would like to express my appreciation to Mr. Singgi Purnomo, Mr. Tominanto, Ms. Paulinda. Thank you for your time and support to this event. To Ms. Normalita and team or crew, thanks. You ask make the expert lecture event. We could not have done it without you. To you all participants, thanks for your coming. I hopefully it can provide insight to all of us. To Mr. Sila. Hello, Mr. Sila.
Hello. Yes.
Hello, Mr. Sila from Hwasyu University in Thailand.
Hello.
Yeah.
Did you hear me?
Oke. Selamat datang di Indonesia, Mr. Sawadee-krap.
Sawadee-krap.
Yeah. Thank you for your time for all of us. Okay, guys. Mr. Sila will talk about of artificial intelligence and deep learning. We will sharing information how to use artificial intelligence and deep learning in Thailand. Well, I do not want to take too much of your time. Once again, welcome to this expert lecture event. It is great to see so many of you here. Thank you very much for your attention. See you. Thank you once again. Thank you, Dr. Sila. Selamat datang di Indonesia. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Mr. Vijayanto. Okay, next is the main agenda of this event, the expert lecture entitled Artificial Intelligence and Deep Learning, which will be presented by Mr. Silatan Sirirkal, Doctor of Philosophy, as a guest lecturer and conducted by Mr. Vijay Lestari, Master of Computer. To Mr. Sila and Mr. Vijay, time is yours.
Thank you.
Oke. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam
warahmatullahi wabarakatuh.
Good morning for all. Wilujeng Injing.
Good morning, sir.
The first, I would like to thank to Master Ceremony, Mrs. Dia, that has given time for me. Respectable, the Dean of Faculty of Computer Science, Duta Bangsa University, Mr. Wijianto, Master Pendidikan Magister Komputer. I'm sorry, I cannot translate the academic title. And especially the Honorable our speaker, Mr. Sheila Temsirikal, Doctor of Philosophy. Welcome and thank you for willingness to be an expert lecturer in this time. And then the Honorable all lecturer in Faculty of Computer Science, Duta Bangsa University. And so, the last but not least, the Honorable all participants of this lecture event. First of all, I would like to thank to Almighty God, Allah Subhanahu wa Ta'ala, for blessing, grace, and mercy. So we are healthy now, inshallah. I am Wijil Stari as a moderator in expert lecture. I am very pleased and welcome in this moment. This expert lecture, the expert lecture about artificial intelligence, AI, and deep learning. I think it is good topic in present area. There are three kinds in the field, in the computing. The first, big data analysis, and the second, artificial intelligence or AI, and the third is physical computing. Physical computing include like Internet of Things. This moment, we will hear a presentation for our speaker about the AI and deep learning. Our speaker today is Mr. Sheila Temsirikal, Doctor of Philosophy. He is lecturer in Faculty of Science and Technology, Department of Computer Science and Digital Technology, Washu Kalam Praktik University. I will read his short CV. Mr. Sheila Temsirikal, Doctor of Philosophy. Dr. Sheila, excuse me when I talk your name is wrong.
It's fine. It's fine. Thank you.
He is PhD from Information Science in Japan Advanced Institute of Science and Technology in 2019, and Master of Science in Information Science also from Japan Advanced Institute of Science and Technology in 2015. And Bachelor of Computer Science from North Bangkok University in 2009. His research interest AI, artificial intelligence, game informatics. I think game informatics is popular and interesting. And then human likeness and believability, and gamification, image processing, deep learning, and brain computing interface. I'm sorry, I don't explain completely because very long. Before the presentation begin, let me inform how to expert lecture will be going on. Urutan dari lecture expert lecture ini ya. First, Dr. Sila will be invited the present the material including mini workshop in perceptron. Perceptron is one of algorithm in artificial neural network. And the second, there will be a question and answer session. The last followed by conclusion. Okay, I think enough, and now allow me to welcome the speaker, Mr. Sila Temsiriku, Doctor of Philosophy, to deliver his presentation. The time and flow is yours, Dr. Sila.
Thank you.
Please.
Did my voice clear for in everyone?
Okay, doctor.
Okay. Let me share my screen first. Let's see here. Okay. Thank you for a warm welcome. And my name is Sila again. Let me introduce myself. I will give you a lecture in artificial intelligence and deep learning. First of all, I would like to, as you already introduced me, as Mr. Vijay already introduced me, my name is Sila, nationality is Thai, and I'm currently a lecturer in Hua Xiao Chalermphakit Universities, whereas we have degrees of bachelor degrees of artificial intelligence. Of course, my specialist is AI, and my works is about human likeness in AI and also game artificial intelligence. And actually, I can speak 3 languages: Thai, Japanese, English. Feel free to ask me in these 3 languages. And today in my lectures, I will give you a lecture in English, but of course, I should say that I'm not mother tongue. I'm not an English speaker at firstborn. So if there's anything is not clear, you can ask me anytime. Okay. Maybe my research is about human likeness. You might think, what is human likeness? So let me introduce you one thing. This is the game called Mario games, and as you see, we have an AI that plays this Mario game very precisely, very smart, right? But think about that when you play a game with this kind of AI, it cannot be. I mean, if it's a game that versus each other, so it is impossible to beat him, right? So what my work is to try to make the AI become more human-like, look like more human, and can be able to entertain human. This is my work in my doctoral degrees. So our topic is artificial intelligence. At first, I would like to ask your question, your opinions. Please, can you answer me about the question? What the words that describe AI in your opinions? Okay, you can answer me here in Mentimeter, so you can go in there and answer some of the words that you think that describe the AI in your opinions, and we will look for it. This is just one answer is come. So please feel free to answer. There's a no right or wrong. So. Oh, okay, there's a many answer right now. So let's see in here, robotic, UDB, IDB, intelligent demonstrates, search. Oh, technology of robotics. Like human, it's very interesting, the answer, right? Like humans here. Okay, thank you for your participations here. And I think the major answer is like robotics or robot or smart or something like smart robot. Okay. This I think is very natural that that everyone think the answer is robot, because it's the thing that we can literally see. So actually I would say that actually the artificial intelligence is the sign of making a machine smart. And smart, in the meaning of smart, what the thing that make human smart is the brain, right? For the so for the machine, it's artificial intelligence. So in other meanings, we can say that AI is a software that simulates human or animal intelligence and ability to handle some human task. So if we see, I'm sorry, I said that AI have ability to handle some human tasks, right? So let's see that what we apply the human, what we apply human tasks, what we apply AI in the human task for, what tasks that we apply AI for. For example, in logistics, now we have currently the robot that can arrangement that can organize the package. First, for example, Amazon, which is the e-commerce site, very large e-commerce sites, They use the robot to organize the package inside the warehouse. In sometimes we also apply AI in agricultures to make the agriculture more effective. We also apply into security and healthcare or production and manufacturing. Of course, we apply into engineering. So we got a robotic science, right? And last, but I don't say last, but another thing is also automotive. Yes, just like we have auto drive car, right? So let's see. In AI just a little one part of the computer science. It's a one part of computer science. Yes, which is we have a network. We have the knowledge about networking, programming, system analysis, computer architectures, or anything else. And so we have AI in this study, in this computer science field. And in AI, we study about search, pathfinding, and everything. So someone's raising his or her hand. So is there any problem? Is that fine? Okay. And inside the AI, we have one science that we call machine learning. It's just a group of the algorithm that we study about how to make a machine learn. And inside this machine learning, we also have one science that's very popular today that is called deep learning here. So it is what we're gonna okay. Let's see. Okay, if you need some resources, I have here. This one is your resources, so you can download today's slide here. Is it okay? Okay, I'm gonna come back to this slide again after my presentation is complete. Okay, and AI, as I say, AI is designed or make a machine smart. We combine a knowledge. We combine We combine many knowledge inside the side of the AI. Of course, first we have a knowledge of computer science, right? And by the knowledge of computer science, we combine with the knowledge of mathematics, and we have the algorithm called machine learning. I'm sorry, okay. We have machine learning. Then we also still need another domain we call a domain expertise. For example, if you want to apply AI into medical field, so you need a knowledge in medical field. If you want to apply AI into engineer field, so you need a knowledge of engineer. if we just use only computer science, if we just use only mathematics with the domain expertise, so we have just only statistical analysis. Or if we just only use computer science in the domain expertise, so we will have just only information processing. If we apply 3 of these science together, so it will become what we call data science. And actually, this is also one part of AI. Okay, one more example, one more question from me. I have one real world problem here. First, I have the first question is, I have a chocolate shop that set prices following 10 pieces for 1,200 baht, 15 pieces for 1,800 baht, 20 pieces for 2,400 baht, 30 pieces for 3,000 baht, 50 pieces for 4,000 baht. The unit, it doesn't matter. You can change the unit in whatever you want, but the price is was set here. And I said that in very soon, I have a new package for 25 pieces and 35 pieces that will be on sale. So what price that these two packages should be? I would like these questions for 3 minutes, please. So you answer just only 2,800, 2,500 or something like that inside this Mentimeter. So first, I would like to ask you what 25 pieces should be. Can you answer? Now there's one answer from audience, 2,700. Is there another answer? $3,000. Oh.
Kita kan di unmute, Bu. Saya di unmute juga, di mute. Udah. Oh ya.
Oh, it's various. 7,000. Very interesting. Maybe 3,000. Mm-hmm. 2,800. Okay, if it is 3,000, so I thought this answer is gonna be for 25 is 3,600 and for 50 pieces is 4,600, right? Mm. Okay, okay. Thank you, thank you. Let's see if it is another answer, another question, another. And for the 35 pieces is 3,500, 3,600, 100, 1,800 watts. To quite little bit low, right? Okay, and thank you for your participation. And I should say that it is your choice that you will choose any answers, right? But one way that you can raise, someone raise his hand. Okay, 3,000, 3,000. Okay. Okay. It is your choices that you can make a choice of prices, right? But if I want 25 pieces, I mean, normally we will think that the price should be between 2,400 and 3,000, right? And if I want 35 pieces, it's gonna be around 3,000 to 4,000, right? So one way that we can answer this question is to make some graph, to plot some graph. So you will see that if I plot some graph that I have 10 pieces around 1,200, 15, 20, and 30, and 50 like this. So we can draw the line graph. I mean, it might not be a straight line. It can be a curved line, like here, like here. So we can predict that if we if we have 25 pieces of the chocolate box here, with 25 pieces of the chocolate box here, so we might be sell in 2,700 bahts, and if we choose 35 box here, so it might be 3,250 bahts. So this just only one possibility, but it is also the problem in the real world, right? And okay, now a little bit more difficult. I have the data on temperature and humidity and how we feel in that day, how we felt in that day. For example, if in that day that have 30 degrees, temperature is 30 degrees with 70% humidity, and the records say that I feel discomfort, I feel not good. And in another day, I have 30% and 30 degrees and 30% of humidity, but I feel comfort. In another day, I have 35 degrees with 30% humidity. I feel not so well, discomfort. And in another day, I have 27 degrees with 80% humidity. I also feel not so good, not so well. And I also have 20%, 50 degree, 50%, 27 degrees, but I feel comfort. 23%, 90 degree, feel comfort. 90%, 23 degree, feel comfort. So from this data, can you predict that if tomorrow it's gonna be 33 degree with 45% of humidity, it will comfort for me. It will feel comfort for me or not. And also 25 degree with 70% of humidity, it will comfort or not. So you go inside here and you answer that 32 degrees with 45 humidity is comfort or discomfort. Just only that. And 25 degree with 70% of humidity will comfort. You feel comfort or discomfort just inside these Mentimeters. So there are so many answers right now, and 32 degree with 45 degree now, feel comfort is leading. Right here, and let's see, 25 degree with 70% of humidity. It's here. Okay, let's say that 32 degree with 45% of humidity, we have majority is a comfort. You think it is comfort, right? And in 25 degree with 70% of humidity, we also, wow. Is that okay? So I should say majority is comfort. Okay, the majority is comfort right now. So, of course, the one way to predict is to plot some graph. It's also to plot some graph. We have 23 degrees with 90, 23 degree with 90%. We have here, and the circle point to the data that means it's comfort. It's represent comfort, and another one is the cross one is mean discomfort. And we have the graph like this, and if you want to separate the data, so we create some line here and separate data into two sides, right? And these two sides, if the data is over the line, over or equal to line, so we said it discomfort. If data is lower or lower the line, data is this data is comfort, right? So what we asking is first, what we asking is 32 degree with 45, 32 degree with 45. So here, so in the first questions, I would say it may feel discomfort. And in the 25 degree with 70% humidity, 25 degree with 70%, I would say it's comfort. But so congratulations for someone who's predicts the same thing as me. But this is just only the possible way to predict. So the answer might be a little bit different from me, but it's fine. Right? These two questions are just only one example, or just only the example of the problem in this world that we try to bring AI to solve it, right? These two, the first one we call the problem, this kind of problem is regression problem. And another one, in this one, we call the classification problem. So this is just only two types of the problem in the world, that which we have many types of the problem in the world. And let's see. I said that I want to bring AI to solve this kind of problem, right? In this box is the name of the algorithm, and just the example, not every algorithm, but some of the algorithm in AI. We have Monte Carlo, we have deep learning, we have machine learning, we have SVM, which is a type of machine learning. We have KNN, it's also the type of machine learning. We have Q learning, we have gradient descendant, we have Knight Bay, we have A-star algorithm, we have artificial neural network, many algorithms, right? To be the developer that develop AI is the thing that is to choose the right algorithm to the right problem. I mean, choose the optimal algorithm for the problem. But there are many problems, right? There are many algorithms, right? Many problems also. And it is hard, I think it is hard. So we have to understand the problem itself. And also we have to understand the algorithm itself too. So today, subtitle maybe. Okay. So today we're gonna learn one kind of the algorithm that we call a machine learning. So if I want to explain every algorithm, it will be hard, and I think if we have no time, so I have just choose one kind of algorithm to explain to you guys. So today I would like to explain you guys about a machine learning. So we should say in AI, in artificial intelligence, we try to imitate human intelligence, right? To imitate the human intelligence, there are many ways. One way is to try to imitate the way of thinking of human. For example, like you try to decide something. So you use some factor. You try to decide which car that you which kind of car that you want to buy. So you use some factors. Just for example, start with which color that you want to buy. Do you like red or do you like blue? If you like red, so I decide that I will buy red car. And do you like Toyota? If you like Toyota, so I will buy Toyota. This kind of the way of thinking is it's like a decision tree. If you are in computer science, it's like a if else sentence, right? Also, we have search algorithm. That's also the tree about the tree, or some heuristic method. Or another way, we can imitate ability to learn of humans or animals. That is a machine learning. So the deep learning is the one kind of the machine learning algorithm too, and it's very popular right now. So let's come to talk about machine learning. If what machine learning is? So machine learning is the algorithm that make some mathematical models for doing the task. Let's, for example, in the last question that we have this one, we have the graph of discomfort and comfort graph, right? And we try to predict the data in that comfort or discomfort, right? By input some temperature and humidity inside, right? And if we build some AI, some machine learning, it means we get input temperature, get input humidity, and predict that this input will be comfort or discomfort. It means in this graph, this line is the thing what we call machine learning. It's the thing what we call models. And machine learning is the algorithm that build this model, this line. Okay. So if I talk in a little bit hard words, a little bit wordy, it means machine learning is the algorithm that automatically improve mathematical model by some experience or data. Is so. So there are so many types of machine learning. I mean, there's three main types of machine learning. One we call supervised learning. One we call unsupervised learning. And one we call reinforcement learning. First one, supervised learning. As the name, this kind of algorithm needs some data to learn and needs some time to learn. They need a time to understand data and after they learn, they can do the task. For example, after they learn, they can classify humidity. They can classify humidity and temperature, that comfort or discomfort. And I'm sorry, I will take a look at the. If you have any questions, please write into the chat, and I will take a look in other after the sessions. And unsupervised learning, we don't need any data, but we will try to find some pattern in the data instead. That is the unsupervised learning. I mean, if you use unsupervised learning, in the time that you want to work, you want to group something, so you just throw the data inside unsupervised learning, and they will try to group it by themselves. And the third one is reinforcement learning. This one, I want you to think about when you try to teach your pet how to give me a hand like this. And first you try to give me a hand, and you bring his dog's hand, his hand to your palm, and you say, good boy, and you give a treat like this, and you repeat this kind of processes. And after several times, dog will learn that if you speak, give me a hand, and he bring his palm to your hand, then he will get a treat. So he will learn by himself. This is the kind of reinforcement learning. So reinforcement learning is the learning algorithm that learn by a reward. And here is very popular image that represent three types of machine learning algorithms: supervised learning, unsupervised learning, and reinforcement learning, along with the task the type of task that this machine learning is good at. For example, supervised learning. Supervised learning are good as classifications and regression. Classification, like the problem that I tell you before, the temperature and humidity, and we try to classify that this temperature is discomfort or comfort. And regression, like the chocolate problem. We have many type of chocolate, but we have many type of package, and we want to predict a new type, the price if we have a new type of package, like that. And unsupervised learning we use for dimensionally reductions. If we have many dimension of data, if our data have many dimensions, so sometimes we have to simplify the data. So this unsupervised learning will help you with dimensional reductions. Also, sometimes we use for unsupervised learning for clustering, group something. If we have the many kind of many pictures, so we want to prove that this is the good picture of the human face, this is the picture. Maybe some unsupervised learning can help. And reinforcement learning used in very few. For example, robot navigation, it's also used reinforcement learning. Okay, let's look at supervised learning. Today our topic is about supervised learning, because deep learning is the one of supervised learning. Well, supervised learning is the learning algorithm that learn from learning data. So we have two phrases. First phrase we call learning phrase. Learning phase is the phase that we try to create the model itself. I mean, this one we call models, right? So we try to make this model, for this example, I want to make this model able to understand that the picture is the picture of monkey. So I prepare some data, some monkey's picture here, and I put this data into the model and tell them these are monkeys. Every time that I put data inside, I said this is monkey. Every time I put inside, this is monkey. So this is expect value that I want from the model, right? From the several times of learning, the model will be able to understand that this kind of picture. If I put this kind of picture inside the model should answer us, it is monkey. This is the kind of the one kind. This is the supervised learning. So let's see. Today, I would like to introduce you one easy machine learning, one easy supervised learning we call perceptron. First, perceptron is the supervised learning that inspired by human brain, human neuron cells. You see here, this is neuron cell. Neuron cell, this is a picture of neuron cell, right? And the neuron cell will contain this. It is this here we call dendrite. Dendrite will receive some input from another neuron cells inside nucleus. Nucleus will process some data and send the output through the axon to the another neuron cells. So here we try to imitate this neuron cell in digital world. This is the digital neuron cells. we call perceptron. It is easy thing that we also have input, right? We get some input data. We get some input data and summarize together and pass through some activate function and go and send output from the perceptron. So this is how the perceptron works. First, I would like to explain you the algorithm itself. It's not that hard. It's not that difficult. So I would like to explain first. The algorithm start with, we have input here. This is input. And every input will have a weight that will make every data, that will make the data, have a different significance. So we start that the input, we multiply the value of input with the weight. Also input x2 with the weight x2 until your last input with the last weight together. And we summarize we sum all of this input and the multiplication of input and weight sum together. And by this summation, we will put it in some function that we call activation function. This activation is easy. We have one threshold value. For the example, this threshold value is 0. If the summations of these thing of the input and weight is below than 0, so this activation function will return 0. But if it's equal or greater than 0, the activation function will return 1. After that, we will compare the result that we got from activation functions to the expected result, 1 or 0. If the expected class is different from the result, then we have to update the weight. The update is easy if the data is positive. I mean, I write it. Okay. If the data is the positive class, and I will explain this later. What is positive class and what is negative class? If it's positive class, so we plus this one into the weight. We pass the input into the weight. If it is a negative class, this one I write wrong. So if this one is the expected class is a negative, so we minus this one from the weight. So let's do some workshops here. So I would like you to download this Excel sheet. I write it for you guys, and please download this. Okay, so here, download this Excel chart, and you will got this one right now. Please. Student here is also, please download the Excel chart here and doing together. So I will let you to download this for 2 minutes. Okay, I think everyone is okay right now. So let's see that this is Perceptron. This is the program that I write in Excel. It's very easy for for someone that can do it together right now, please. So I think you will be understand Perceptron better. So the Perceptron, what the Perceptron is the linear classification. So the thing that we want to do is like the example that I told you here. So we want to draw this line. This line is the perceptron. So if we look into this file, I didn't give this file to you. I would like at first we will do this problem together. I have this data. This data, that means if I got first input is 0 and the second input also, if I got first input is 0 and the second input is 0, so the result that I want from this the 0 0 is 0. But if I have 0 and 1, I want the result become 1. If I got the input 1 0, I want result 1. If I got an input 1 1, then I want 1. Okay. Then what we want to do is try to separate this data like this. Okay. So let's see in here. So I put the data here for you guys already. So if I got data here, input 0, input 0, input 1 is 0, input 2 is 0, I want expected output 0 here. 1 0 1, 0 1 1, and 1 1 1, right? If you are in computer science or related to computer, I think you will already notice that this is an OR gate, right? And OR a logic operator OR, right? And here we need another thing that we call biases. So as I said that I want the perceptron will create any problems. Yeah, it has a password for changing column sheet, but here I don't want you to do any change in this column. So at first you can change this column only. So I will give you a password in the end of the presentation. Okay. So at first, okay. I said that we want to create a line that separate the data into two sides, right? So when we say the line, it means we talk about linear equations, right? So for the linear equations, let me show you. This So, okay, for the linear equations, you will see that this kind of linear equation, let's see, 0 equal x plus y plus c plus 1, right? This is a linear equations, right? So you see that you have the x, you have a with x and some a with y, some b with y, and c, right? If you don't have c, this c is the thing that in our perceptron we call bias. If we don't have c, it means your data will just only change here and here, right? 3, 1, 2 here, right? And if we don't plus c, it means your line gonna have no change here, have no unable to shift left or shift right, right? Plus 3, plus 10, plus minus 3, right? If you can't do that, I mean, you cannot make a line properly. So we need the thing we call bias here, and bias must be set at first as 1. So we will have 1, 0, 0, and our expected output is 0. 1, 1, 0, our expected output is 1. 1, 0, 1, 1. 1, 1, 1, 1, right? Okay, to train the perceptron, we start by choosing some data. I will choose this data first. You can copy here, copy it, and paste here. When you copy it, it's pasted here. The perceptron you start to multiply this input to get this input and weight together, and the result will be here. The result will be shown here. I mean, this have no change. Let me change this one to this one first. I will change this one first here. And after you copy this one to this one, this one to this one, you will see that the result has been changed here. So you see, let's see. First, 1 multiply 0, we get 0. 0 multiply 0, we get 0. 0 multiply 0 gets 0. And summarize of this all, we will got 0 here. And by the activation functions, as I say here, by this activation function, if we have 0, it means the result gonna be, output gonna be 1 here. And if the output, let's see, we have output as 1, but the thing that we expect is 0, right? So this expected output is not equal to, it's different. So we have to update the weight here. So if the output, we see, we will look at the expected output. If the expected output is 0, it means the result is negative. The data is the negative data, because we want the line. We want this result, the data, lower than the line. So it is a negative data. So we have to minus this data into the weight. So our new weight is gonna be this one. This one will be new weight, our new weight. And after we got first round, so we choose another data. Let me choose this one first. I choose the data tree inside here. After I choose this data inside, we see that the data will be multiplied by the weight, right? And this one, 1 minus 1 equal to minus 1. 0 minus 0 multiplied by 0 is equal to 0. 1 multiplied by 0 equal to 0. And when we summarize this, it will be minus 1. Put it into the activation function. Our outputs, it's going to be 0. But our expected function, our expected class is 1, which is different from here. So we have to update the way. So we put this data is the positive data. So we have to plus all data inside the weight, right? Yes. Okay. So when we input inside 1 plus minus 1, we got 0. 0 plus 0, we got 0. 1 plus 0, we got 1 here, right? So this is our new update weight. So we put inside here. And if we look in this test data, I mean, this test data, I try to simulate that if we put this data into the current perceptron, which data that he gonna predict it false, it's not correctly predict. So you will see that the first one, it's still not correctly predict. So then we try to copy the first one again and put inside the third round. Here, by repeating this process, you will see that the third round, you will still have a data that not correctly predicted as the second data, right? This one, right? So we try to copy here and paste at fourth round. It still have this one is incorrect data. So we will do this one again. And at last, our model predict every data correctly right now. So this is the last model. This is the model that we got for this perceptron, for this data. So this what this model look like? It means this is C, right? And this in linear equations, 0 equal to ax plus by plus c. Here, if I got here right now, so this means this one is C, and this one is A, and this one is B. This means we got the line that 0 equal to x plus y minus c minus 1, which is in here x plus y minus 1 here. Like this. So it means our perceptron gonna be like this. And if the data is over than this line, over or equal to this line, it will return 1 for us. And if it's under this line, it will return 0 for us. So this is our perceptron right now. So I give you this this Excel sheet that you can change the data here. This is in all circuits, right? Or logical operator, or right? So you can change this one to the logical operator and, like you have to delete this one first. This one, to delete the data first, and we can change this one to 0 and this one to 0. So this is gonna be logic operator and. So here, and you can try by yourself to with an operator. I don't know what we have a time or which we have time or not. But here, if you want to make a change in this slide, so you come in you go to review here, and you select unprotected sheet. I think my password is 1234. So you can unlock the sheet by yourself. So maybe you can do it, this kind of data and data by yourself. 1 1 0 0 is 0, 0 1 is 0, 1 0 is 0, and 1 1 is 1. Yeah. Okay. So so as you see, this is a perceptron, right? This perceptron can represent the line, the linear equations. But how about, and you see that the perceptron is also able to represent an logical operator called and logical operator or. So we can, if we connect everything, we connect the perceptron together. So we can express more complex model, not just only one line, right? So when we connect every perceptron together, when we connect multiple perceptron together, we will call it is multi-layer perceptron. And after we adding some multi-layer perceptron, we'll update the weight of each perceptron by feed-forward approach. If we combine some technique called backpropagation, these multi-layer perceptrons will be called as artificial neural networks. So let's see here. Here you will see that we have a data, two types of data, purple one and red one. The purple one, we want to separate this one, right? If we use perceptron, it's going to be like this one. This one is not, actually this one is not a perceptron, but it can give us the same result because it's also the linear functions. So if you use perceptron, you will got the result like this. You will have a line that over the line will return a red one, and under the line will return this one. But if you combine if you combine perceptron together and use some backpropagations, your expressions will be more complex. So you can represent this kind of line, like this curve, or not just only curve, but it's also can separate more data more precisely. So in artificial neural network, we have three, we construct it systematical, and we have three layers. First one we call input layer, which is which we put input inside here, all input inside here. And the second one is the hidden layer. In this layer, it will contain a perceptron and some algorithm we call backpropagations. And here we will learn the thing that we put inside. And the last is the output layer here. So as I said, that if we increase the number of perceptron, the thing that we can express, the feature that we can express will become more complex. And also, if we increase the number of hidden layers, the thing that machine can learn will be more abstract, will be more, you have more possibility to learn the many types of data. And this is what we call deep learning. As you see, artificial neural network, we have just only one hidden layer with one input layer and one output layer. But in deep learning, we have one input layer, multiple hidden layer, and one output layer. And with this approach, approach that we try to increase the hidden layer. I'm sorry. With this approach, we can learn more complex things. For example, human facial, or the thing that we call facial recognitions. So in deep learning, we can learn human face by we have input layer that we put our facial picture inside here. And after that, deep learning will try to understand about the pixel of each picture and the line that in the picture, because our picture is just only pixel that continue together, right? So they will try to understand each edge, each line in the first layer, and in the second layer, they will combine this understanding together and try to understand more complex shape. For the example, this is eye, this is eye, this is nose, this is eyebrow, for example. And in the last layer, it will combine the knowledge in the second layer together and try to understand. This is called face. As you see, the data, the understanding of in deep learning will become more complex, will become more abstract. Not just only understanding age. And at last, bit by this layer, they will able to understand that this is the picture of face. So just this is the explanations of the previous slide. So I give you that the first model try to understand the value of data in the pixel, and the second try to find the relation between the pixel and identify age or shape. And third, identify more complex shape, and fourth, identify human face. Sorry. Okay, today I talk about perceptron, ANN, artificial neural network, and deep learning. As I said first, we need to choose the right algorithm. Deep learning is very powerful. They can learn about face, they can learn about the picture very well, they can classify the thing very well. But of course, they have some cost that we have to pay. For example, it need a data, big size of data. Also, we need a time to make them learn. And we need very large resource. We need a RAM, we need CPU, good CPU. Compared to ANN, that the expression is more, it's a little bit poor than deep learning. Not a little. The expression is poor than deep learning, but the implementation is easier than deep learning. But it not take a result as deep learning. So developer, but instead of deep learning, in deep learning, you don't have to find any feature for them. So they will extract the feature automatically. But instead, if you choose ANN, you have to tell ANN which feature that ANN have to focus on. Of course, if we use just only perceptron, the implement is very easy. It's fast calculation, take no resources, but expression is more poor. It's just only linear expression, right? So if you have just if your data is just only linear, separable, so we use perceptron will be better. So as I said before, as I said earlier, choose the right algorithm will be better. So at last but not least, if you want to be AI developers, the knowledge that you need to focus, of course, first thing, you need to focus about the programming skill. Java, C#, C++ is the common programming skill, right? And in very recently, Python is very popular language. So if you have this knowledge, if you have knowledge in Java or C# or C++ plus knowledge in Python, so I think the study of AI is not so hard. And definitely to understand AI algorithm, you need some mathematics skill. As you say, in the perceptron, we use just only.
Excuse me, Dr. Sila.
Yes.
5-minute remaining, yeah.
Yes.
Yeah, 5-minute remaining.
Okay. 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 Thank you. Sorry, I'm sorry. You need mathematical skill, right? It's very important. So in perceptron, we just only use plus, minus, and multiply. But in deep learning, we need some, for example, partial differentiation, like that. So to understand it clearly, you may need this kind of skill. But for use, it might not so that mandatory. And the last, you might need another domain expertise. If you want to develop AI, medical AI, so you need some medical knowledge. But I think it is hard to understand another knowledge, another domain, because you cannot learn by just reading in the thing that doctor learn. But we can do something else. We can find someone that expert in your area and collaboration together. So to work as team, you need some communication skill, right? Okay, at last, 70 years ago, one famous mathematician called his name is Alan Matheson Turing, leave us the question, can machine think? So it is a dream of someone that to make the machine be able to think, be able to talk to human. I said we come so far. We have come so far in 71 years. We come so far, but it is not a half. It is so far to go. So as I say, we have many things to accomplish. So I think we need a new generations of researcher, new generation of developer for AI. I think we need you guys. If you have interesting in AI, so we very welcome. So thank you for your attentions. I don't know that my English will be your problem or not to understanding, and my story it might be a little bit hard to understand or not. But I think if it inspires you guys, I will be appreciated. So if you have any questions, I appreciate to answer.
Thank you very much, Dr. Sila,
Yes.
for giving us such information and interesting presentation in AI and deep learning. For all participants, now come the question and answer session. Because this time is tour price, so we need just for first term and the last term, yeah. Just first term. I would like to have 3 questions from the participant. Please, operator, help me. Please raise hand for the make question. Please, operator, help me to choose the participant who give question. Just 3, yeah, because this is almost tour break. Yeah.
I have these questions. Which one I should do? This one first. As Mr. Sila said earlier, that deep learning is the one is popular in our algorithm recently. My question: what is the difference between deep learning algorithm with another machine learning algorithm? So deep learning can be very popular. What's a deep learning can be popular? Okay, actually, deep learning is not a new algorithm. The idea of deep learning is very old. I mean, because we try to imitate the brain, right? We try to imitate the brain. So we have perceptron that is one cell of the brain, right? So we try to connect this perceptron together, right? So, and we also understand that these perceptron, when we combine this perceptron together, the expression will be more complex. And we understand that we have more hidden layer, it will be more complex. But in the previous day, in 20 years ago, in 10 years ago, our technology, our computer is not good enough to compile this thing, compile deep learning. So then we wait until our technology become able to handle this kind of computations, and we start to try. We start to experiment, and we found it very, very interesting. We found it very powerful. Then, in very recently, in many data, the moment that let the deep learning become popular is the moment that if you know the AI name AlphaGo, ALPHAGO, which is the AI of Go, which is try to use deep learning fight against the world champion of Go, the game of Go. Win against Lee Sedol, and that moment is the moment that make deep learning become more popular. And after that, we try in many domains, and it say that it's very interesting that the deep learning can handle the answer field, can handle the problem field. The second question that I have here, what will I do when I start learning AI? First of all, as I said, your programming skill have to be good. So let's start programming skill and try to find some knowledge in YouTube. It's very better. And I have my this. If you're interested in machine learning, this book called First Course in Machine Learning is very interesting book. So I think you can find this book, this kind of book, and you can try to try to learn.
Excuse me, Dr. Sila.
Yes.
I think there are two raise hand. Please, I'm sorry, Dr. Sila.
Yes.
There are two participants for raise hand. The first, please, Martia. Please, Martia, mention your complete name and where do you from. Then please give question to Dr. Sila.
I'm sorry.
Okay. First, I want to introduce myself. My name is Dia from Firstly, Mr. Sila. Explain that mathematics is a fundamental basic in learning artificial intelligence and deep learning. According to Mr. Sila, what tips are needed or what for someone who has no interest in mathematics but intelligence and deep learning? Thank you.
Please, can you repeat the questions again?
Please repeat, Martia.
The signal is not quite good, so I cannot hear the question clearly. So can you repeat the question again?
Martia, please repeat your question.
As I can hear, I can hear.
Again. Previously, Mr. Sila explained in learning artificial. According to someone who has no interest in mathematics but intelligence and deep learning. Thank you.
I still not understand the question. Is that if you have no interest in math, but you're interested in deep learning or machine learning, what can you do? Something like that. Excuse me. Okay. Chat. Explain that mathematics is one of the intelligence and deep learning according to what tips are needed to do some. I mean, it is hard to say that if you have no interest in, you cannot learn machine learning, you cannot learn AI, because you can. Actually, you can use, but to understand it clearly, I mean, there are many tools in the world, right? If you are in computer science, you already know that there are many libraries, the library in Python, the library in Java, that you can learn this kind of the thing. But you won't be able to understand if you cannot understand inside what the calculation is. My tips, actually, I would like to say that actually I am the one who didn't like math that much at first, but I try to make and understand, not just only, not just only talk, not just only read, but I try to understand this topic. What about this topic, and why this topic is what this topic is for. For example, differentiation. So if you learn mathematics, just only differentiation is to decrease the degree of the equations. So it's just over. So I think you might learn that differentiation is the technique that try to understand the trend of the equations, how the equation is going to be in future, something like that. If you try to understand like this, I think even you cannot do it by yourself, but you understand the technique of you will understand the technique that used inside the mathematics, that used inside the machine learning or deep learning itself. So I think maybe not you don't have to learn hard, you don't have to make it hard, but just a little bit look into the math. I think it's better.
Okay, Dr. Sila.
Yes.
The next participant will give a question. Please, Bintang Saputra. Bintang Saputra, please give question.
Ya, Pak. Iya, Pak.
Yeah.
Hai,
I
Mr.
hope
Sila.
short question because
Yes.
Yeah.
the time is 12 o'clock.
Iya, Pak. I'm Bintang Adi Saputra from Technical Computer. I want to ask about deep learning. What are about deep learning? What are examples of deep learning application in the health sector?
What are example application of deep learning?
Yeah.
Okay. The applications of it, deep learning can be, if you ask about an application of deep learning, I would say you should go to find Alpha PHA group. This is the first application of deep learning that I think about. This is the application of deep learning. You see, this is DeepMind, but it's also in many in many fields has been used deep learning. For the example, face recognition. The deep learning technique called DCNN, Deep Convolutional Neural Network. This one is a very popular technique in image processing field, and it is applications of deep neural network. So I think if you have interesting, you can read about the deep convolution neural network. It might be interesting.
Thank you.
Okay.
Okay, yeah.
Okay.
Okay, excuse me because the time.
Yes.
We cannot get solution for all questions. All participants, we finally come to the end of this expert lecture. Before I return time and floor to Master of Ceremony, I would like to take conclusion from what the speaker has presented. The first, AI is computing paradigm that make machine smart, like human in acting and thinking. AI are applied in various domains. From the AI, there are machine learning. Machine learning is part of the AI, and deep learning is part of the machine learning. Deep learning is one of popular machine learning algorithm, and it improved by more layer. There are three kinds of learning in machine learning. The first, supervised learning, and the second, unsupervised learning, and the third, reinforcement learning. Okay, thank you very much for Dr. Sila.
You're welcome.
Thank you very much for Dr. Sila. And allow me to welcome to speaker, Dr. Sila Temshirikal PhD to, I'm sorry. Once again, I would like to thank the speaker for the information and interesting presentation. And then time and the media, I return to the Master of Ceremony. For me, enough. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Okay, thank you, Mr. Sila and Mr. Viji. That was a great lecture from Mr. Sila and also Mr. Viji. We do hope we can be more knowledgeable regarding to artificial intelligence, technology, science, and also the deep learning. Okay, ladies and gentlemen, for your information, the attendance list can be filled in the link that we have provided in the chat. In bahasa, untuk presensinya silakan dapat dilihat di dalam chat. Linknya sudah dibagikan dalam chat. Video ya Bu ya. Oke, untuk peserta silakan dapat mengaktifkan videonya karena akan diambil gambarnya. Oke, semua peserta dimohon untuk mengaktifkan semua videonya. Oke, diambil siapa? Sudah. Oke, sudah ya. Okay, ladies and gentlemen, finally we have come to the last part of our agenda. I would like to express my appreciation to the all participants for taking time out of your busy schedule to join this round. Thank you for your attention and apologize if any word that less pleasing to the audience here. Let us closing this event by saying Hamdalah together.
Alhamdulillahirabbil alamin.
Alhamdulillahirabbil alamin.
Okay, thank you. See you next time. Billahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you.